Calculate the area enclosed by one loop of r equals to cosine 2 theta. Let's graph this object. We have 4 loops for this object. 1 loop, 2 loops, 3, and 4. It must be symmetrical, but I'm using marker to graph this. And we want to know what is the area of just one loop. One loop, so let's just take this loop here. And we want to know what is this area. You can calculate either of these loops. It doesn't matter. You get the exact same result. Take a look at this one loop here to understand its behavior a little bit better. If theta is equal to 0, r becomes cosine of 0, which is 1. If theta is equal to, for example, pi over 4, here you have r, theta is equal to pi over 4, your r becomes cosine of pi over 2, which is 0. If theta is equal to, for example, pi over 2, your r becomes, here you have cosine of pi, which is -1, and so on. This is what we learned in elementary calculus, right? You can just graph this object. This object was initially written in x and y. They used polar coordinates to convert that into r and theta, because now you have a nice compact formula to work with. And this object, one loop, is not bounded between 2 fixed values. It starts from, for example, the origin and starts expanding, but the expansion depends on this function. What is this function? This function is r equals to cosine 2 theta. R is cosine 2 theta. So this guy is r equal to cosine 2 theta. So the double integral calculating just the area is double integral dA, dx dy, or dy dx. But since we are converting everything into r and theta, we're going to use the polar coordinates. dA becomes r, dr d theta. Well, r is bounded between 0, and the maximum value it can take is cosine 2 theta. The maximum boundary, the maximum value is cosine 2 theta. So r is bounded between 0 and cosine 2 theta. Well, what about my theta then? So theta is equal to pi over 4, r becomes 0. Also, theta equals to negative pi over 4, r becomes 0. Or by looking at the graph, take a look at the graph. Here you're looking for these two lines, line segments touching the graph, right? So take a look at this scenario. Here you have your r equal to 0, cosine 2 theta is equal to 0. 2 theta is inverse cosine of 0, which is equal to pi over 2. So my theta becomes pi over 4. But since we have symmetry, this angle is pi over 4, and this angle is negative pi over 4. Pi over 4, negative pi over 4. So my theta is bounded between pi over 4 and negative pi over 4. The rest is just elementary calculus computation. So this guy becomes integral. Can I separate these two? Note that here you have a boundary which depends on theta. So take a look at this. Negative pi over 4 and pi over 4. And here you have a half r squared. R is bounded between 0 and cosine 2 theta d theta. Perfect. So this guy becomes a half integral negative pi over 4 to pi over 4. And here you have cosine squared 2 theta d theta. We have to go back to pre-calculus and simplify this as much as we can. Cosine squared of, for example, alpha is equal to 1 plus cosine of 2 alpha divided by 2. Or you can write this in sine form. Okay. Cosine squared of alpha 1 plus sine 2 alpha divided by 2. So here you get a half, and here you have integral 1 plus, let's just do the subtraction, do the division here, a half plus sine of 2 alpha, which is now 2 times 2 theta, divided by 2 d theta, negative pi over 4 to pi over 4. So this guy becomes a half, and here you have theta divided by 2, and here you have minus, let's see, 1 over 8 cosine 4 theta, and theta is bounded between negative pi over 4 and pi over 4. So let's see, if I plug in pi over 4 and negative pi over 4, okay, let's just write down everything, theta divided by 4, I have 1/4 pi over 4 minus minus plus pi over 4 or pi over 2, and here you have minus 1 over 16. Take a look at this, you have cosine of pi over 4, or just pi, minus cosine of, here if you plug in negative pi over 4 and multiply by 4, you get negative pi. All right, so these two, they get canceled out, and you're left with 1 over 4 times pi over 2 or pi over 8. So this area is equal to pi over 8. If somebody asks you, hey, then what is the whole area? You're going to multiply this by 4 and you get pi over 2 as the area of the whole object, r equals the cosine to theta.